Data scientists have a very tough job. They have the responsibility to communicate complex ideas to decision makers who are probably not as mathematically or statistically sophisticated as they are. But they need to do it in plain terms. These decision makers just want it simple. Just give me the answer. It's really never quite that simple. Just give me the number. But when you're building a predictive model, the number that you might give would be the most likely value, but we have to understand there's a distribution of values around that with varying probabilities. It's the responsibility of the data scientist to communicate that in a clear way. Otherwise, bad decisions can result. Let me give you a very specific example. So imagine that you are the mayor of a city, and there's a hurricane coming to town. And you go to the person who's predicting how much rainfall is there going to be. And that person says, there will be 18 inches of rainfall on this day. And the mayor says, that's great, because the levee is 20 inches. We've got 2 inches to spare. Well, this is actually a true story, unfortunately. And the mayor made the decision that the city did not have to be evacuated because the levee was going to hold. The problem is 18 inches was the most likely value, but there was a distribution of plus or minus 4 inches around that. And when the rain went above 20 inches, big problems happened. Now, if you were the data scientist, it is your job not just to communicate the most likely value, but to help the decision maker understand the distribution of values. And using terms like standard deviation and so on, that's not going to mean anything to most decision makers. You have to put it in terms that they understand. I believe as data scientists, based on the analysis that's been done, that there is a 80% confidence that the rain will be between 14 inches and 22 inches. That's very different than telling 18 inches is the answer. And really, the question is not posed in the right way. Really what you want is to understand what is the likelihood that the rain exceeds 20 inches. So it's the job of the data scientist to understand really what is the question being asked. The question being asked is not how much rain are we going to get. The question being asked is the levee going to be high enough to prevent flooding of the city? The data scientists would spend time understanding really what the problem is, not just the mathematics to do the prediction of, in this case, what the rain is. And I can give you lots of other examples for retailers who are trying to predict how many sales based on the inventory they have on hand, because I don't want to ship inventory to the store that I don't need. But on the other hand, if I have an out of inventory position and I have unhappy customers and I might get fined. So the state of California, if you put an item on sale and there's not enough of the item, the store gets fined because they've done bait and switch to get people into the store. So there's a cost to getting it wrong. We need to understand really what is the question being asked. Not the face value of the question, but the problem trying to be solved. Data scientists need to spend the time to do this.